Issue 305, 945 subscribers. What's the puzzle? Nice little picture one. What's it got? This week's puzzle. Logan, Heidi and Daisy are having a party, and it's up to me to put the 10 kids into pairs for the first game. How many ways can I do this? How many different ways can I pair them off? Well, here they are. Now, there's 2 ways you can do this. There's a long way and there's a short way, but it has to be random choices. You can't look at that and think, oh, I think I'll pair off Gormless and Glaikit for a 3-legged race, because then they'd be falling over all the time. And no one would want to go along with Little Miss 4 going on 40 and just get told off all the time. No, it has to be random. Well, the long way would be just make a list of all the pairs. Can't have 1 with 1, so 1 with 2, and then just go through all the pairings with 1 with each of the rest. If that was number 1, you could have 1 with all the remaining ones. And then all the ones for 2, if that was number 2. Well, I can't have 2 with 1, I've done it already. I can't have 2 with 2, so I'll have to start with 2 with 3. Then the same for 3, but 3 would have to start with 4, because I can't have 3 with 3 and I've got the other ones. And so on. So there's all the pairings, whoops, get you the right way around. There's all the pairings that you can have for these 10 children. How many is that? Well, there's 9 in that column, and then they go down in ones at a time. 9, 8, 7, 6, 5, 4, 3, 2, 1. Adding that all up, those are the going pairs. 10, 20, 30, 45. There's 45 different pairs you can make. That doesn't mean the answer to the question is 45. That just says there's 45 ways of choosing a pair out of 10. So out of the 10 of them, for instance, choosing this pair, there were 45 different pairs I could choose, so there were 45 ways of choosing this pair. But the question isn't just choose one pair from the 10, it's make them all into pairs. Well, that means independent of this now, because they've now gone out of the equation, I've got 8. How many ways are there of forming the next pair? And that'll be an independent choice to this one. Well, that's the same as knocking them out of the equation. I'll just put the 45 above them. And then adding up these numbers instead. So now that would be 10, 28. So there's 28 ways of forming a pair out of these. So I'll take them. There was 28 ways of choosing them. Now I'm left with 6. Forget them, they're out of the way. If I had a group of 6, how many different pairs could I make? Well, that would just be knock this out. Now I'm down to just 15. There's 15 pairings, so they can come across as a pair. Now I'm down to 4. How many different pairings can I make from 4? Well, there's 6 left, so I'll take this pair. And of course, that just leaves 2 left on their own. Glaikit and Spud, so they have to form the last one. There's only one way of picking out the only 2 that are left. Now they were all independent choices. For each of these 45 pairs, there was 28 ways of choosing the next one. For each of them there was 15 ways of choosing the next. Now I've got a multiplication for the total number of ways. And if you multiply that out, it comes to 113,400, 113,400 different ways. But that's not the answer, because these pairs came out in a certain order. That would be the number of ways, for instance, if it was a 3-legged race. That would be the total number of ways of them finishing. So this would be one example of them finishing, them coming first, them coming second, them coming third, them coming fourth, and them coming fifth. That would be one of this number of ways. But if you're only interested in that particular grouping of 5, then it doesn't matter who comes first, who comes second. What doesn't matter is different rearrangements of these pairs. But they've all been included in this. So that's far too many. There's one of these for each of the different arrangements of these 5. So how many ways are there of arranging 5 things, 5 pairs? Well, that takes you to the second way. Well, out of the 5 of them, there's any one of the 5 could come first. Once they've come first, any one of the 4 could come next. Once that's happened, any one of the 3 could come next, times 2 times 1. There's that number, which is 120. Which means in this, there are 120 repetitions of the same group of 5. Just that group of 5 appearing in various guises. Ooh, come back you. Not time for ice cream yet. So dividing that by 120 gives you 945. And that's the answer to this one. 945, which you may notice is the same as the number of subscribers. So what's the quicker way? Well, the quicker way is essentially doing the same thing as that finishing order. How many ways can I arrange pairs in this? Well, if there are 10 children to start with, there are 10 ways of choosing the first one. Once the first one's chosen, I've got 9 ways of choosing the next one. So I've got 10 times 9 ways of these 2 coming out, but that includes both orders. Her coming out first, then him, or him coming out first, then her. Which means each pair has been included twice in there. So divided by 2. Now there's 8 left. How many ways of choosing the next pair? Well, there's 8 ways of choosing this one, and there's 7 ways of choosing that one. Includes both orders, so divide by 2. And so on. Now I'm down to 6, so it'll be 6 times 5, 4 times 3, and finally 2 times 1 over 2. Notice that pattern. 10 times 9 times 8 times 7, that's 10 factorial. I've got 10 factorial over 2 to the power 5 ways of them coming out in a particular order. But you already had that. Those five pairings, I don't care which order they come out in. Those 5 pairings have got 5 factorial rearrangements, so also divide it by 5 factorial. That would be the number of pairings that you could make. And you've got the factorial button in your calculator anyway. Equals 945. Now, as well as there being a notation for this 10 times all the digits 1 less than it till you get to 1 being factorial, there's also a notation for this. That's a combinations notation. That says how many ways are there of choosing 2 from 10. If there are 10 objects, how many different combinations of 2 can you make? So essentially that's 10C2. That would be 8C2, 6C2, 4C2 and 2C2, which is obviously just 1. And the way that you work this out is you would say 2, so it's the first 2 that are coming out. So 10 ways times 9 ways divided by the number of arrangements or rearrangements of that same pair. If I had 12C3, that would be the first 3 coming out over the different arrangements of those 3. Still, the answer to this was 945. Notice it was the same as the number of subscribers.